So carbon, as Archie would say, our colleague, and sustainability, it's everywhere. Everybody's talking about it. But I guess we come at carbon from a different perspective of that quantity surveyor viewpoint. Us being specialists in quantum, specialists in cost, change management, etc., we're also putting our hand up and saying, look, we'll take control of the carbon aspect for you to our clients, and then work very closely with the design teams in order to be able to deliver carbon and kind of procure carbon from the contractor and supply chain, etc. But this new Carbon QS, can you explain that a little bit to us for our listeners out there, and of course anybody that's interested in this new forming role?
We kind of touched on it lightly last time, I think, in one of the previous ones. It's mainly because it's just a natural fit for quantity surveyors to do it. To start off with, probably the most useful structure that exists in the whole of the kind of carbon sphere is the whole life carbon template, because it follows pretty much the same format that a traditional quantity surveyor is used for. We follow the same order of building parts, and we follow the same life cycle stages as you would follow for whole life cost. So section A is the equivalent of your CapEx, section B is the equivalent of your OpEx, your section C is demolition, and D is one of these bolt-ons on the end that will evolve and become more important the closer we get to 2030, because it's like a pot where you can stick these things like offsets and those circular economy and all those kind of things.
And they will definitely become more prevalent in the future. I'd imagine the circularity aspect will, as sustainability progresses towards biodiversity and circularity, it's the inevitable evolution of it. I would think. But the whole life calculation, whole life standards, they come from the RICS. Is that right? The Royal Institute of Chartered Surveyors.
Yeah, they do have a framework there, and like I say, it parallels life cycle costs, so it is quite a natural fit for us. And it's the best tool that's out there at the moment, because there's a lot of ideas, a lot of aspirations, people championing different ideas, different models, but they only tend to cover specific parts of the whole life. So for example, if you think of people might have heard of CREM. There's 7 stages in the section B, but CREM technically only cares about 2 of them. So it's not like CREM looks at the entire of section B. And when we talk about doing LCA calculations in a country like Denmark, or in any country, virtually almost every country uniformly leaves out certain life cycle stages. And it is inevitable that sooner or later those stages will have to be added in. It's just some people leave them out because they think they're currently too small an impact, or it's too difficult to calculate it, so they just leave it out for now.
So I guess what we're looking at is the low-hanging fruit when we are calculating carbon, which is why some of these smaller components aren't really looked at the moment. But the inevitability of that also is that we will begin to calculate whole life carbon in its fullest sense in the future, when we become more efficient at greenifying the volumetric components within the building. That's what I expect anyway, at least.
Yeah, because the story historically has been the starting point was what we would call B6 operational energy. So you go back to the 80s and 90s, it was an easy sell to get people to make buildings more energy efficient, better insulation, appliances that have higher energy ratings. So B6 came down, but it's a halving. So if you make it 50% better and 50% better and 50% better, you can't carry that on forever. And the same's happening with embodied carbon. So as you get closer to zero, it's inevitable you have to put in these missing life cycle stages, but also this section D that's like the forgotten stepchild has to come back in, because it will become virtually impossible to make that final step to net zero without using something from section D.
Yeah, and I think that's a very key point at the moment, because a lot of countries are building their standards and their processes towards the carbon requirements and reporting. Like Denmark, for example, as we have discussed on the podcast before, has its standard, and every building above 1,000 square meters now needs to have its carbon or LCA calculation. But when you look at the whole life carbon aspect, not everything is taken into account. So the inevitability here is that in the future we will. But coming back to that carbon QS then, like, there's lots of softwares out there at the moment that can calculate, your embodied carbon, your LCA. Why would you need the Carbon QS quantity surveyor on your project? Why do you think that they're, the solution to servicing the industry?
Part of the problem is that a lot of these things, the whole space is generally quite new, and a lot of the tools in it are quite new, and they take, like Microsoft, we're not using the first version of Microsoft's operating system. There has to be a process of iteration to allow certain things to become better. And it's not necessarily the software's problem. Sometimes it's a research gap, or there is an assumption that undermines it. So if you take, the softwares are all perfectly fine in certain instances, but just to give you an example, so we'll mention two things. One is CREM. CREM is key is the second most key sort of document, because it deals with assets that are already built, and you're supposed to be able to try and use it to work out at what point in time your existing building will strand according to decarbonisation. So even something that is being built today at today's standards is not necessarily future-proofed. And as I'm saying, CREM currently only cares about 2 out of the 7 sections. So it's inevitable at some point B2, B3, B4, B7 even though they're small, or too hard to put in, have to be put in. At some point, this preferred tool of everybody's has to adapt to fit the whole life cycle picture. And with the softwares like the LCAs, they're not a complete solution. They are something that should fit within a overall arcing system. If I just take like an example with the softwares, Letty a few years back tried to create some benchmarks for four most common types of building: apartments, schools, offices. And they took a couple of different sources. So they used one of the main softwares, a main database, and 2 consultants. And for each of them, they came up with what they thought was the average across their projects. And the gap on one of the most common building types was 40% between the consultants and the software. So somebody somewhere's got a problem. And another problem with the software is some of them have information biases, because they're built on EPD certificates. And it's obviously people who have green products will produce EPDs. People who have really bad products aren't going to produce EPDs. And there are some, if you take the 2 key carbon drivers, concrete and steel, using an average for concrete doesn't make sense, because you can only procure concrete locally. You can't import it from France. You can get your cement maybe, but that even doesn't work out quite that way. And maybe a better example again is steel. Some of them will just take the average of the carbon in steel, say, produced in England, which again doesn't make sense, because the steel market is made up of domestically produced and 50% imported. And most of the imported steel will come from just 6 to 8 countries, will cover 80% of it. And if China and India are your top 2 imports, you're going to have a very high carbon imported steel average. If you're a country maybe in the EU that gets it from, say, Spain, Italy and Sweden, you're going to have a much lower imported that creates your aggregate. So there are problems in all of these different things that need to be ironed out with the different iterations, which is why it is far better as a carbon QS to not put all your eggs in the basket of, here's a software or here's a thing, I'll use the thing. it's a good starting point, but what you need to do is invest in your own research, your own tools, so you can spot errors and plug them so that you can get to the correct answers.
So we can see a lot of the industry is kind of pushing heavily towards the softwares as the solution for calculating LCA. And what we're kind of saying, in reality, they're part of the solution, but they're not the whole solution. You as an expert need to understand the output that the softwares are giving you. You need to be able to qualify the information being used so that you, when advising your client, have a good understanding of that quality level in the calculation. It sounds very familiar when we change carbon and replace carbon with the word cost. If we're using softwares to automate unit prices, for example, the unit price of something in Copenhagen versus Aalborg is very different. The unit price of something in London versus Manchester is very different. So it's sometimes very difficult to automate that estimating process. You still need an understanding or information from the market to be able to facilitate it, and someone to be able to qualify that the information you're receiving is high quality, medium quality, low quality. And that's where that Carbon QS comes in.
The softwares do have a role where they're particularly useful, but if you imagine the whole life cycle of the project or the built asset's lifespan, there are times when it comes in, and maybe I'm jumping the gun here getting towards built asset management. There are times when certain softwares are particularly useful. The softwares are virtually useless at the very early, at business stage, the concept and feasibility stage. They can't really start to be useful until the design stages. One of the things, again, that we've noticed there that's quite interesting, if you look at Sweco's database, they actually, in theirs, they were listing what the carbon was for different projects at different stages. So you could have concept feasibility, early design, late design, as-built. And you can see they were jumping sometimes up or down by 20 to 15% in some cases. So you can see that we weren't even looking for that at the time when we were building up our database of databases, if you like. We just these things, when you start to do your research, you suddenly start finding problems you hadn't even realized that were there that you need to account for.
Yeah. And that's the qualification of this information, and not just taking it verbatim and using it, but actually understanding what it is that you're using. And one of the other aspects that has come to mind when it comes to this Carbon QS over the last number of years when working is also the strategy around how you manage carbon in a similar process to how you manage cost. So setting that budget at early stages, you mentioned that, inception and the business case and feasibility study stage, etc. We benchmark for cost. We benchmark to develop early stage budgets with set criteria around contingencies and risks and variances, etc. The same process is for carbon. So it's not a case that you just go to a software and punch in some numbers to get a result. There's a entire strategy and approach to this process. I guess that the Carbon QS has a lot of experience and ability, because what they're taking is that transferability of knowledge from the cost management process to the carbon management process.
Just to give you sort of an example. So say we have somebody who comes in at like a concept and feasibility kind of level, and they say, I want to build X type of building. And from a cost perspective, you're using, say, cost per square meter from the most similar buildings. In the same way, we have a carbon database. So for each, just as you can have, like with SPONS, a price range and an average for a type of building, we have carbon data for different types of building as well. So you can see the average school is this, the average apartment is that. And then there's some further detail we can go into with different frames, different types of building standards. So we can see what the average starting point is. And for a country like Denmark, this will become increasingly important, because when we first started with the regulation, it was a hard measure with a slow start. So it's 12 kilograms per square meter going down to 10.5 to 8. And it was achievable because SBI had calculated the average of buildings, so it was not painful. But already we're changing those regulations. So instead of next year being 10.5, it's going down to 8. Because, as we mentioned last time, with kicking the carbon can down the road, if your curve looked like this and you don't do enough, your curve now has to do that. You've got less time and it gets steeper and steeper. So if 12 was the average starting point, and we see a lot of buildings that are around, benchmarking wise, around 9. So next year when we hit 8, some of those building types are going to start to struggle a little bit. So already at that business case stage, someone's got to be able to look under the benchmarking and say, as we did for one the other day, the historical average is 9.6, you want to achieve 8. So we've got to get you down to 1.6. So at business case stage, I have to budget that cost already. And ideally, I need to budget that cost based on an understanding of a hierarchy of what is the most cost-effective solution to bring that carbon down.
And that comes back to the strategy point I was talking about. It's not just getting a calculation now and having a target. You need to be able to strategize of how you're going to get there. And by doing that earlier from a benchmarking perspective and understanding your data source, it means that you become very focused on the areas to reduce that component to carbon. So I think coming back to our main point here is that Carbon QS it's not an estimating role. It's not a software calculation functionality they're providing. It's the strategy of how we get there and making sure that that's implemented very early.